Good afternoon, everyone, and welcome to the final installment in our series of webinars for Industrial Electronics N6. We kicked off with N4, and then when there was a curriculum change for N5, we presented a webinar to assist lecturers about all the changes in the curriculum, and now we're unpacking the changes to the N6 curriculum. So welcome to the final presentation, and as usual, we've got our well-respected and renowned author, Clifford Tobajane, to conduct today's presentation. I'm sure you've enjoyed his books, you've enjoyed using his books, and he's authored the N4, N5, and co-authored the N6 book together with R. Gobi. So just some background about Clifford. He's qualified in electrical engineering, qualified as a facilitator, assessor, and moderator. He's got a professional teaching qualification. He's got vast experience in both internal and external exams, marking and assessing. And previously, he's worked as an assistant electrician at Nkula Electricals and also at Denzel Electrical sub-Eskom. So it's over to Clifford to take you through today's presentation. Thank you very much.
Thank you very much again, and good day to everyone who has joined us today. And as mentioned, I'm C. Tobajane, the author of this industrial electronics books together with R. Gobind. In today's session, we'll just be focusing as usual on the curriculum changes for industrial electronics N6. Remember that this curriculum will be implemented from January of 2025. So it is expected that all colleges must then be able to use the new curriculum book, so that it can be easier for students to transition. Let me also again emphasize, colleagues, that in this trimester of 2024, this September trimester, the curriculum for industrial electronics N5 is already implemented. It means that in your studies with the students, you must be using the new textbook so that it could be easier to peruse through the examination. This goes with the industrial electronics N4 that was implemented last trimester. Now, I've had quite a lot of our colleagues in other provinces that could not get the information for the new curriculum, and as expressed, their results were quite disastrous. Can we try, colleagues, to minimize such events and at least be up to date and order these books immediately, so that it could be easier for the students and not to have them write an unfair examination. In today's session, we'll just request again, colleagues, that we fully participate, more particularly by the end of the session, where we deal with questions and answers. I would encourage everyone to ask questions where possible. Because this would be the last revised subject in industrial electronics, I would, at the end of the session, allow everyone to ask questions, whether for industrial 4, 5, and also for industrial 6, so that we could easily move and try to assist one another where possible. I would also share my contact details in the event where you prefer an individual inquiry, and then we could assist each other where possible. However, this is also the great platform to be able to discuss what you might want to know about the new curriculum. In this webinar, like again as explained, we'll be discussing the curriculum outcomes for the new textbook, the impact of these changes, and how the TVET first textbook is created to support your teaching and learning in your classroom setting. And like I'd mentioned, this would be implemented in January of 2025. That means that from January, the old textbook that you are using would no longer be applicable for a student to sit for an exam. So could we kindly please make our orders as early as now through the procurement officers so that we could get our books delivered on time in January. Now, the general aim of this curriculum is to equip our students with the knowledge and fundamental principle of electronic industry. This is to assist them improve their skills and further their career prospects in the electronic field. Now, with the N6 curriculum, this is actually in a nutshell what a student must be able to be equipped with. And they must be able to apply these learning outcomes in the technological principles. Now, these outcomes would be the transient and transducers, ultrasonic, X-ray and radio activities, electronic safety devices, thyristor devices and SCR speed control, PLCs, and the new kid on the block, which is robotics. Now, the requirements for an external assessment or final examination, if you may, would not have anything different in terms of its rules. The paper is still out of 100 marks, and the duration of that paper would be 3 hours, and it's still a closed book. Here, a student will still be provided with a formula sheet, and they will be allowed to use scientific calculators that are not programmable. Copying and using external papers in the exam room still is prohibited. All these examination rules that had been applied in the previous curriculum would still be applicable on the new curriculum. However, I want to believe that by now we know how to calculate our ICAS mark for our students. It is still placed at a minimum of 40% to qualify to write an external examination. And the ratio is still calculated at 30 to 70, 30 being 30% of the syllabus covered in a classroom settings, that is test 1, and 70% or 70% of the remaining content of the syllabus covered in classroom. Now, the combination of that should make up to 40% minimum for a student to qualify to sit for the external examination. But also take note that during the promotional mark or the awarding of the final mark for the students, the following rule will be used. The ICAS mark obtained by the student. Suppose they've obtained 60% qualifying mark to sit for the exam. That 60% will be multiplied by 0.3, which is 30% of the ICAS. Alongside with the added final examination mark that the student would have obtained from writing their final exam. If perhaps they've obtained 52%, they will multiply that by 0.7, which is 70% of the exam mark. The both will be combined to produce a promotional mark that would allow the student to progress to the next level. But here's what I want to stress most, good people. This is something that I've been experiencing for quite some time. When we speak of 30-70 of the ICAS mark, here we are speaking in reference to the syllabus that is you are using in your classroom setting. A syllabus, the student must write test 1 then when they've covered 30% of the syllabus. That is according to the time frame that is placed to complete the whole book, which is a 10-week course. 30% of the syllabus must have been covered before the student could write test 1. In the event of, or in the case of industrial electronics N6, that means at least you should have been covered 3 modules. Then they write a test based on those modules that they've completed. 70% speaks of the remaining modules that you need to cover also before they write, which means that if there's a question in module 3 that you had asked in test 1, You can't ask the same module in test 2. You are not fairly assessing the student. Instead, you are repeating a module that would not be happening in the exam center. So you assess a student on test 2 based on the remaining 70% of the curriculum modules. Then you combine the two to make 100% of the covered syllabus. That is how you properly assess your student. The last part is when you create an assessment, because I believe that in colleges, we are now using the common assessment approach for all campuses in a college. When you create an assessment, this is to ensure that the assessment conforms to the standard of final examination. You use your syllabus to guide you on how you should ask your questions. The questions should not be of the standard of or less than that of the final examination. It should be equated to the same standard of the final examination, just like the curriculum prescribes. The curriculum has stated its learning outcomes in or learning units in a question form. You use that information to generate your test type questions. By doing so, you are exposing the student early to understand the language used by examiners. And that way you'll be able to, expose our students to pre-examination questions, and subsequent to that, you obviously get some good marks. But let us look at the changes to each module, and then later on discuss the deeper understanding of what exactly these highlighted changes or overviews mean. For module 1, the module is still on transient. Now, in this module, we have the curriculum is prescribed more details on the RL and RC circuits, as well as the RLC circuits. In the previous curriculum or syllabus, these details were faded. They were very vague, hence you'd find that the student would answer questions that they would probably not be exposed to during their classroom settings. But now the curriculum has made it clear on exactly what is it that a student must know in the RL and RC, as well as RLC circuits. And there are some new contents that are added in an RLC circuit that student must also be exposed to. Module 2 is about transducers still. There are some new contents and some new explanations that have taken place across the attenuation, offsetting, and there's some much information on interfacing and the analog combination circuits where we deal with operational amplifiers. There's just more detailing in the curriculum. The compensation and scaling has been entirely omitted, or rather removed from the new curriculum. It does not form part of the industry requirements. Hence, it has been entirely removed. Module 3, now we've combined ultrasonic, X-ray, and radio activities. In the old curriculum, ultrasonic was a module on its own, X-ray and radio activities was a module also on its own. But in the new curriculum, this has been combined to form one module. And there's just some new contents being added under radiations, and the radioactivity has been described, also prescribed in details. There's also some separation in terms of a detailed explanation between an ultrasonic welder and an ultrasonic solder. In the previous curriculum, detailing was not that much, and you could see more similarities between the two than differences, which made it a bit difficult for students to be able to distinguish between the two. But now there's just some separating terms that have been included there that would properly describe the two in terms of its practical application and operations. There's some new content concepts being added in the piezoelectricity, the magnetostriction, and radiation detectors. However, the old section 12.3.1 has been omitted, alongside with the calculations involving a photomultiplier tube. The concept of photo multiplier tube is still there in the curriculum, but there isn't any calculations there. So it's just some information and stuff, but not calculations anymore. Automatic inspection, testing, and NDT. There's a combination of two learning outcomes, 12.5 and 12.6. Those have been combined to make one learning outcome, and there's just some new concept in the inspection methods that have been introduced. Like I said, would go into details in each module so that you could see exactly what is it that has been added and what are those that have been combined. The new concept regarding the high-pot test, dielectric voltage withstand test, the insulation resistance test, and the use of a megometer. There are just some small additions there that one should take advantage of, but the fault detection and calculations involving an oscilloscope have been entirely omitted. My good people, if you had remembered that we, even in N5, I could not remember exactly in N4, the concept of oscilloscope entirely has been removed. And in my previous explanation, when we're doing the webinar for industrial electronics, N4 was that such that is an old technology for measuring that was used in the industries, and it's no longer having an industrial relevance because they are now using the liquid crystal display to monitor signals in a circuit. So even with N6, the entire oscilloscope section has been entirely removed. This includes its calculation as well. Electronic safety devices. Now the old curriculum section 12.7 is still maintained. It is not yet removed, but there are just new learning outcomes. 17 of 23 of those outcomes for industrial safety devices that are entirely new, and also new concepts of optoelectronics, safety light curtains, and safety interlocking switches. Those are just new concepts that a student must also know. And there's just more details on intrinsic safety. This includes the distinguishing between the series productive elements, and Zener barrier protection. Just some little additions there that the student must also know before writing an exam. Electronic power control, we have some new concepts on the open loop system and closed loop system, of course. The computerized aided design and computerized aided manufacturing systems, there are just some new contents that have been added there. But now the uninterrupted power supply, there's just more details than before. On how or what exactly a UPS is and what it entails. Some additions of details in that aspect. Thyristors and SR speed control, new terms that have been described under this section have been introduced, and before you realize that there were not much focus on these terms, they were just blindly mentioned in the curriculum. But for this new curriculum, the examiner would also require a student to understand all these terms and their meanings and what the purpose are of these components. This would include the firing angle, thermal resistance, the base and junction temperature, DC chopper, freewheeling diodes, the switch loss, heat sink, and so forth. These are the terms that a student must understand and know with respect to their applications in the industry. The industrial battery chargers have been entirely omitted, and we will deal with that section when we get there behind the reasons why industrial battery chargers have been omitted. PLC, with some new learning outcomes, 16 of 22 of those learning outcomes are new, and a student must be able to grasp those new contents and some more details on the old learning outcomes. So it means that there isn't anything that has been removed with regards to the programmable logic controllers, but some detailing on what is it exactly a student must know has been added with some fail-safe device content that are entirely new. And like I mentioned earlier, the new kid on the block, which is robotics, with all its 11 outcomes being entirely new in industrial electronics and 6. Remember, we're slowly moving away from the 4th industrial revolution and clearly embracing the 5th industrial revolution. And electronics would be irrelevant without coding and understanding of computer language. Hence, robotics is included. Remember, when you deal with a programmable logic controller, it also speaks of coding. When you deal with those gate circuits, they must be coded for them to understand what is it that they should function as. This is where robotics come in, and this is a very exciting module, I have to tell you. So the mark allocation or mark distribution in this curriculum are as follows. This is how marks are now redistributed across each module. We have the transient, weighing of about 10% of the final examination mark, transducers 10%, and ultrasonic and X-ray and radioactivities, because the combined, these are 2 combined modules. They weigh about 15. Automatic inspection testing and NDT 10%, and electronic safety devices 10%, electronic power control 10%. So this is how basically marks have been distributed, which I believe is very visible in your screen. Unlike N4 curriculum, where the mark distribution had been made in such a way that a student could just get into an exam and write only module 1, 2, and 3 and get 55%, which is a very great pass. With industrial electronics and 6, it means that it is required for a student to know at least more modules than less in order to at least obtain a pass. So I'd encourage ourselves, good colleagues, to make proper preparations before class attendance so that students understand all the contents in each module in this subject. However, there isn't anything difficult. Industrial electronics N6 is actually the simplest subject in N6 level, which is a win. Now, the mark distribution based on the cognitive level are as follows. As you can see there, this is how an exam is actually set, is actually structured, if I may. The marks are not just distributed however the examiner may like, but they have to follow this curriculum to instruct them on how you are going to distribute marks, right? So for knowledge and understanding, the mark allocation should be between 30 to 40 marks. That is knowledge and understanding. And knowledge and understanding, we're dealing basically with theoretical concepts in the test. So between 30 to 40 marks, that is what the examiner may be looking at. Application, this would deal with probably calculations between 45 and 50. Sometimes some small drawings, or completing a certain drawing, or fully labeling a drawing if an examiner decides to give you that. And analyzing, synthesis, and evaluation would include the designs of circuit, more particularly with PLC, where one will be required to design a logic controller for a traffic light. Right. That is where you now have to analyze information that is given to you and obviously evaluate how your design would subsequently operate in that space. This is how an examiner actually distribute their marks. Now, I want us to look at exactly what each module entails and what you should expect. What are the little details that have been described in each module, right? So we have these 4 learning outcomes or learning content, if I may, for module 1. The student must be able to understand what are transient behaviors in DC circuit, the RC and RL circuits, as well as the ranging circuits. But the content that have been added, like we mentioned earlier, is such that a student, for this case, has been critically outlined by the curriculum that they must be able to draw a detailedly labeled time or current versus time diagram for a charging and discharging of a capacitor. Before, there hasn't been much detail on this, but now the curriculum has prescribed it to happen. We understand that with regards to an RC and RL circuit, the student who, by the order of the old curriculum, calculates the time constant, be able to calculate the voltage for charging and discharging, the rate at which current changes. But now there's that one concept where they must calculate the maximum current, which is a new addition in that content. If you are charging a capacitor, what is the maximum current allowable to charge that type of a capacitor or to energize the inductor, if I may? Now, the same thing will be required for an RL circuit to draw the characteristic curve of a charging and discharging of an inductor, or as I like to call it, to energize and de-energize an inductor, and also calculate the maximum current that will be present in that inductor. Also take note, with regards to transient behavior in a DC, it's still as is. There are no much changes, no additions and no omissions there. They are still as is. RLC circuits or the ranging circuit, this is what the student must know at the end of the curriculum or this module. These are all the prescription by the curriculum. This is what exactly the examiner will be assessing our student based on with regards to RLC circuits. They must be able to explain the principle of operation of an RLC circuit, the concepts of ranging, the advantages and disadvantages of the effect of resonance circuit or resonance in ranging circuits, difference between this damping in relation to the square root sign and circuit response speed. They must be able to, as prescribed also in the old curriculum, but vaguely, the logarithmic decrement, the oscillation train time, as well as the highest value of the resistance of the oscillation, and also be able to draw the labeled damping curve. But that damping curve is still prescribed as is. There are no changes. However, there's also no changes between the explanation of what a critical damping, over damping, and under damping is. And there are no changes on the structure of that curve. There isn't any changes. Everything is still the same. However, it's just the curriculum now prescribes more. Good people, what the curriculum actually does is it assists us as lecturers to guide our students in the right direction. Unlike before, the curriculum will just speak vaguely on what a student must know and does not actually describe what in its contextual form a student must know. But in this case, an examiner will not ask you any question that is not prescribed by the curriculum. In some instances, examiners even take a question as it is in the curriculum, because now it is the learning outcomes have been detailed in question form. So having the whole curriculum is like having a scope for the final examination for your students. What I normally do is I share these curriculums with my students, I mean these syllabuses with my students, to guide them on what exactly they should study and what exactly they should be looking at. So it has been greatly assisting me. I advise all of us, dear colleagues, that we also take that, have our students have the syllabuses with them, so that in their study sessions they could be guided. What is it exactly that they should expect in the examination and how an examiner would ask questions. right? Now, module 2, we are looking at the transducers. Under transducers, we have 9 learning outcomes or learning content. Some of these learning contents were merged under one learning unit, but now the curriculum is prescribed that they have to separate into different outcomes. We have the basic transducer theory, the data acquisition systems, amplification, attenuation, linearization, offsetting, signal conditioning, and interfacing. These were previously under the data acquisition systems, and they were not muchly detailedly explained in the old curriculum. Then there's the analog combination, where we speak mostly of operational amplifiers. Now, under the basic transducer theory, this is what a student must know. They must understand what a transducer is, explain what they understand about the terms passive and active transducers, and they must also be able to draw the block diagram of a transducer, name the main components that makes up a transducer, and also give the classification of transducers, the difference between sensors and transducers, the factors that need to be considered when selecting a transducer, the difference between sensors and actuators, a difference between active and passive transducers. All these types of things that you see on your screens are exactly what is being prescribed by the curriculum. It means that if a student goes to the exam and understands all of this, then they would have done themselves a very huge favor. Data acquisition system, this is what they must understand, the ways in which data is acquired, and the major classes in which instrumentation systems are categorized. They must also, remember from the old curriculum, be able to explain this specific term, that is amplification, linearization, signal conditioning, attenuation, offsetting, and interfacing. That content is still kept intact from the old curriculum. But with this one, there's also some detailed explanation on this content. Hence, they've been then placed differently in their own respective learning outcomes. Attenuation, what is added with attenuation are the typical attenuation network is applied to operational amplifiers and the purpose of the attenuation network. Hence why I said some of these things have been detailedly explained. And offsetting, we need the typical application of offsetting and also draw the sketch of an offsetting circuit diagram and a linear voltage divider. But with regards to amplification, linearization, and signal conditioning, they've just been extracted to be separate units, but there isn't any much changes in those. So what was used in the old curriculum would definitely still apply in the new curriculum. Interfacing, this is what now the curriculum has stipulated a student must understand. And there are also calculations precisely described on the dropping and the input feedback resistors. And then lastly on this module would be the analog combination circuits, where a student must understand the operating principle and also draw the circuit diagrams of inverting and non-inverting amplifier, and also understand their differences. However, the stuff that has not changed are the properties of the operational amplifier, the characteristics of an operational amplifier, and also to calculate the feedback resistance, input, output voltage, and input resistance of these operational amplifiers. Those are still prescribed as such. No changes there have been prescribed. Module 3, ultrasonic, X-rays and radioactivities. We have 4 learning content: the ultrasonic theory, ultrasonic application, radiation and radioactivity. Now, under the ultrasonic theory, this is what we're looking at. Like I said, there's some new contents that have been detailedly explained, which is the piezoelectricity and drawing its diagrams for the piezoelectric crystal, and the magnetostriction, also drawing the magnetostriction core, and also understanding the DC bias applied to it, and the properties of an ultrasonic wave, also detailedly explained by the curriculum. On top of the ultrasonic, the practical applications. Remember, I also mentioned that there's some huge terms that have been introduced to differentiate between ultrasonic solder and welder. And also, a student must understand how to sketch and also state the operating principle of this ultrasonic solder. This would include the drawing of this ultrasonic solder. However, the industrial applications of ultrasonic solders, properties of cleaning materials, and the description of tool tips, and all the ultrasonic welding, working with radioactive materials. Practically, there isn't much that has been omitted. Some of the content here are still intact from the old curriculum. However, it's just the detailed description that one must understand. Radiation, you must understand what is meant by electromagnetic radiation, the K-shell emission efficiency of X-ray production, ionizing radiation and X-rays, also the characteristic radiation. One must also understand the properties of electromagnetic radiation and the electromagnetic spectrum, the production of X-rays and the generation of X-ray by means of a diagram, and how X-ray can produce photons. This is some of many of the outcomes that you must understand in that aspect, on how radiation is formed. But the diagram of an electromagnetic spectrum and the construction of the modern X-ray tube still the same. There hasn't been any redesign. On top of those learning units, there are also calculations that are still there, where you need to calculate the supply voltage to the X-ray, the short wavelength produced by the X-ray, the frequency of radiation, the power dissipated by the X-ray tube, the X-ray power in watts, percentage efficiency, and the current drawn by the tube. Those are still there, but now there are some just smaller equations that one may also need to take advantage of. Radioactivity, there are details that are there. We also need to be mindful of them. Under the radiation detectors, radioactivity, non-ionization radiation, ionization radiation, and the likes. There's some small details that have been added there, alongside with the inert gases and also the semiconductor detectors, amongst others. There are details that one needs to understand, but the gas field detectors and the ionization chamber proportional counters and the likes, their operating principle are still the same. There hasn't been any tampering with those. Module 4 speaks of the automatic inspection, testing, and NDT. We have 3 learning contents: inspection methods, automatic inspection, testing, and metal detectors. I think those are more or less some of the contents that have been there. However, there's just some additions and a detailed description of what the curriculum may require from a student, from both inspection, automatic production, testing. But on the metal detector, there is no changes, no additions, no omission. that content is still as it was in the old curriculum. And by now, I want to believe that colleagues do understand how much changes have taken place in the new curriculum and how important it is that we secure the new books for our students. Electronic safety devices. We have industrial safety devices and intrinsic safety devices. Detailed description by the curriculum on what exactly is required from a student, the difference between electrochemical and electric safety devices as applied to various industry applications, the advantages of fitting electronic safety devices, the difference between the types of electronic devices, and so forth, as you could see listed there. Now, there are some few diagrams that have some additional details, particularly with the TVET first textbook, because we tried to bring more practical sense to these circuit diagrams than just an ordinary circuit diagram that sometimes is deemed confusing. So there's just some small details that were identified to, in the past, be creating some short circuit when they are applied as is, and some major corrections needed to be made there. Also, when we speak of safeguarding tools, we need to also be cautious about those. The safety light curtains have some detailed explanation on it, safety interlockings and intrinsic safeties. Also describing with reference to an intrinsic safety what is a hotspot, abnormal condition, energy level, the loop concept when evaluating equipment, a margin of safety under the worst possible condition, transformer construction, an isolation by an excapulation, So we would also be looking at those. Also some more detailing on the hazardous areas and zones, more particularly in workplaces. But there is no much changes with regards to industrial hydraulic punch press. It's still there where you would use a light safety device that when obstructed, it disabled the machine to operate. That is still there. Smoke detectors and flame fail detector devices. There isn't any changes or omission on those. Some of this content have been kept as they are, and then there are not much changes. The only thing that is made is just a detailed description of what exactly is required. Intrinsic safety, here we'll be looking at the series protective elements, the shunt protective elements, and the Zener barrier protective element. The student must know how to draw all three. This would then allow them to come out safe in the exam. The description of intrinsic safety, the steps that are required to determine an intrinsic safety, and the diagram that shows the various energy level with regards to intrinsic safety, those are still the same. But section 522 was omitted from the syllabus document. So that is what has been removed with the intrinsic safety. Like I said, have yourself the syllabus so that you can be able to understand those parts. Electronic power control and SCR triggering, we have three learning contents, which is the open and closed loop systems, the computer-aided designs and computer-aided manufacturing systems, and also the uninterrupted power supplies. Some detailing on those. Now, a student must know how to draw the open and closed loop system and give also their description and the difference between the two, and also they must also name and explain the follow-up systems under the open and closed loop systems. But the basic categories of this concept of control systems are still there. However, remember that when you are dealing with a silicon controlled rectifier triggering circuit, there will be damping that would occur in that circuit. So we are still going to be looking at all those label diagrams that describes these types of damping, the 3 types of damping. And of course, just like in the previous module, we would still be required to explain these damping. The operating principle of a servo control and the functions of feedback control, the sequential control, the servo mechanism, they are still there. There isn't much changes, but details have just been added. However, there isn't much changes on those. But in the curriculum, some details are required. The CAD/CAM system, there are no changes or omission at all. What we had on the old curriculum is still new. There hasn't been any new industry developments between these systems. Still, there's the design, and then there's the manufacturing, following those processes that needs to be followed. But like I mentioned, details have just been reported. The uninterrupted power supply, UPS, there's some details being explained here. Remember, we said that we had removed the industrial battery charges because the system of a UPS as a whole on its own has been described into 2, into a domestic UPS and an industrial UPS. So there's no need then to bring in an industrial battery charger, because then there's an industrial UPS on its own. So in a way, we may say that concept has just been integrated under the industrial UPS. Now, there are some small contents that have been made here: the transfer type UPS and the switch mode power supply, the advantages and disadvantages, and also drawing the block diagram of a UPS and the description of each block. Now, the part of drawing block diagram, my good colleagues, if you were to take note, in each block diagram that would be required to know, or a student that will be required to know in the curriculum, there would definitely be a question that follows up to say, describe now the description of each block. Unlike the old curriculum, you just draw the block diagram and that's it. But now there's the description of what does each block mean. How does each block function to assist the next block? So that is the description. So many of these block diagrams have that detailedly described. The uninterrupted power supply, its description has not changed. The categories of the uninterrupted power supply, like I mentioned, no changes. Also, the types are still there in the basic type of the continuous type and industrial UPS systems. Like I mentioned, removal of the industrial battery chargers and focusing more on the industrial UPS system instead. We have the silicon control, or rather the thyristor devices and SCR control. Here we need to understand the 4 learning content of this module. Where we're looking at the SCR trigger device and characteristics. All highlighted in green is what the curriculum needs exactly the student to also know. It's just what has not been detailedly described in the old curriculum. DC line communication as well. The student must be able to draw a DC chopper using parallel capacitors. If I may remember, there is one that in the old curriculum that uses a unit junction transistor. That one has been removed. We only look at this one. And commutation, SCR, switching and SCR off, the commutation methods, and as well as the parallel capacitor commutation, resonance commutation, and damping requirements are still as is. There are no changes, but the TVET first book has made it an exciting module. The rectifier circuits and devices, where we are now in detailedly looking at what a freewheeling circuit is, the losses that would occur in the mains of a circuit, switching losses, and also you must be able to calculate the value of the capacitors in these circuits and the minimum on and off time for an SCR, as well as the load resistors. So that is what now the curriculum prescribes. But we still have rectifier circuits as is, advantages of both AC and DC motor speed control. Obviously, when we speak of AC and DC motor speed control, we are in reference of an SCR and a triac. And we are looking at the precautions that must be taken for an SCR to be triggered. Those are still intact. There are no changes. Also, when we look at the information that are required under rectification, where you need to calculate the average voltage, PIV, and the likes, those are still there. There are no much changes. That is under the learning content 7.3. But with converters, just some new additional information that needs to be understood, and also understanding what regenerative braking, plunging braking, and dynamic braking are with respect to braking techniques. So these are what I have been detailedly described, and subsequent to that, some detailed content in the curriculum. And some, of course, are still left as is, and of course that gives our students some little advantage. The programmable logic controllers. Now, here we also have, like I mentioned, the green parts discuss what had been detailedly explained and what now the curriculum emphasizes on. The description of the programmable logic controllers, the advantages of the logic controllers, and having to describe the terms hard wiring, soft wiring, relay logic, ladder diagram, and the likes. There are so many concepts under a programmable logic controller. In a short spectrum, when we speak of programmable logic controller, we are speaking of a computer on its own. Hence, I said that the hardware of a computer alongside its software, together those combined would give you robotics, which is the next module. So when you have to understand all these terms of CMOS, RAM, and EPROM and all that, those are what are entailed inside the computer in a form of a hardware. But also you'd also find terms like logic circuits that need to be programmed, that makes them a circuit that reads the software, and that would require coding. The features of a PLC and the difference between sorry, the hard and soft wiring, relay, and logic, because these almost have more similarities, so we need to be expanding these differences. So basically, that is what you are looking at with regards to a PLC. But the block diagram of a PLC and the brief description of that block diagram of a PLC still remains. There hasn't been any changes. Industry still requires it as is. Fail-safe designs still very important, especially when you are designing a logic circuit. We made an example of designing a traffic light. There must be what we call fail-safe circuits. This would come in as a backup in the event where your design fails to operate. What comes in as a backup? So we'll be looking at those, and as well as how we program the programmable logic controllers by making use of AND gate, OR gate, NAND gate, and NOR gate, and the likes. And of course, there will be a truth table. That is part of analyzing. That determines what will happen if switch 1, 2, and 3 are on, and 4 is off if we are talking of an AND gate controller. And drawing the ladder diagrams, we still have them as they are, the on and low logic gates, no logic gates. We have the symbols that are there. Remember that a student might be asked to draw all the symbols contained in a logic ladder diagram. The no contact, connection, timer, internal relays, and so forth. Those are prescribed there. And lastly, on this module, the new kid on the block is the robotics. Now, like I said, we have 11 units here, and our students must know all of them. Here, a student must list the subcategories of electronics under the hood of any robot. All these sub-electronics in a robot must be listed. Explain the purpose of a dual H-bridge motor drive, which is the L293D integrated circuit. List the advantages of this L29D IC and also draw that L29C integrated circuit, showing all their pins. On top of drawing it, you must explain what each pin of this L293D functions as. What is the function of each pin? Now, the L293D integrated circuit is more or less like the dual inline integrated circuit, which we call it an amplifier, where you have a 4 DIL and a 14, if I'm not mistaken, DIL, where you need to understand the functions of each pin there. But with this one, it operates based on a truth table, just like the logic gates. Like I said, these are hand in hand. So here you look at what will happen if you connect pin 1 and 7 to an input, this and that, to an output, this and that, to a trigger circuit, and that to an oscillator. So that's basically what this means. The purpose of the sensor in robotics, the purpose of motion controller in robotics, and also draw the block diagram of motion control system, and explain the different parts of motion control systems, because on its own it's a circuit. So it has some components there and the functions of each part in the control system. So this is not, you know, deeper robotics concept. It's more or less like an introduction to robotics, you know, just to give a sense of mind of what exactly is happening. But here, when you are lecturing this module, it's important that you also have your student, you know, try out coding. But before coding, just to assist, I'm not promoting anything, but there's a software that I normally use, which is called Tinkercad. I think you guys must know of that software, where you get to design and code a circuit and see how that circuit operates. It has the option to also simulate that circuit. So I normally use that in my classroom because, you know, our curriculum does not allow for our student to go into workshops. So I use that circuit to design a traffic light, right? We design a traffic light with my students, take them to a computer center, have them open up their own accounts in that software, and we design the traffic light and we give it time delay. So it has the option to code there, but the code, you know, it's so simplified that you understand what, when you tell it to turn the light green after 5 seconds, it will give you a code on what exactly the code should look like when you are designing it elsewhere. So by doing so, a student gets to practice the computer language and its coding. So you must try it out, good people. This, you know, pre-exposes our students to what the industry might need. Now, we've spoken about the changes that are there in the curriculum. I want us to look at what the Industrial Electronics N6 TVET first textbook will have for you, and how it will assist you in the day-to-day running of your classes. Now, the book comes in a pack of 3 contents. It has the student book, the lecturer guide, and the workbook. Just like Industrial Electronics N4, 5, and 6. So we have the student book, the lecturer guide, and the workbook. All these work hand in hand to come in as an aid to your class. The lecturer guide obviously would come with some background information about the curriculum on its own. You'd find what exactly is required from you by this curriculum, the suggested teaching plan, which I also use as a work schedule, if I may put it that way. That helps you on how to deliver your lessons. So what I normally do is I just copy that suggested teaching plan, file it in my POA, and that is my teachings, my work schedule. I don't do any edit whatsoever because it's written in weeks and not in specific dates, and it has the option for you to write in your lecturer name and the date with which you'll be using in. There's also a lesson plan template that is departmental approved, which is the one that is needed in your files. Comprehensive answers for all activities and summative assessment in the student book, and also starter activities. And there's also a practice exam in the student book where the marking guideline would be in your lecturer's guide. This is just to give you an idea of what you should expect in the exam. Also, at the same time, it comes in AD for the students to pre-expose themselves to exams. Now, here's something that was amazing. For Industrial Electronics N4, when we first wrote our examination in August, and I was holding the previous question paper, I could not believe that the examiner actually almost used the TVET first textbook to generate question exams, because everything that was there in the textbook was also there in the practice exam, and some of the contents that are there in the book were also there in the final examination, exactly as they are. And hence I managed to assist my colleagues in the college with this book. My college obtained 100% pass rate in industrial electronics across the college, 7 campuses. So what we did with this industrial electronics books, we ensure that the questions and examples and summative assessments alongside the practice exam are external examination standard worthy. There is no example that will just be a by the way type of an example. It is specifically designed to meet the exam standards, which came in very handy. I'm just looking forward for this exam in November to see if we'll still have the same thing, but I want to believe that will still happen. The workbook is designed to complement the student book. It means that the activities that are there in the student book and the summative assessment will also appear as they are in the workbook, but they would also provide spaces for the students to answer them. If the question in the student book requires a student to draw a circuit, the question will still appear in the workbook requiring the student to draw the circuit, but just below that question, there will be an adequate space for this student to be able to draw the circuit, alongside spaces provided for calculations, making it ideal for classroom and homework use. Now, personally, I use the workbook to monitor the understanding of my students. And also, they also use it to monitor themselves. What I normally do is I'll tell my student that each and every day you must write an activity of the learning outcome that we've studied. Before you write a test, I want to check your workbook if you've answered all the questions that are there. That would be a requirement for you to sit for my test. And trust me, all these workbooks are utilized. And the same thing I've used for test 2. So in my understanding, once a student completes the workbook, that means the student is ready for the final exam. You'd never be disappointed. Now, there are some meaningful activities that will help the student engage. They could also use those to work in pairs or in groups to answer them. And the answers of the activities and summative assessments, it keeps them neatly organized. Like I said, there will be a space for each and every activity. And there are some revisions aid to prepare them for the exams and some tips on what they should know when they are studying for the exam. Very nice. So this is how the workbook would actually look like. There would be a question, spaces, a question, spaces. These spaces are enough for the students to use. This would definitely expose them for the final examination. The special features that will be here on this book would be the overview and outcomes for each module. All these modules will have overviews and outcomes. So this is what a student must know at the end of the session. All of that is there in the book. There is also the starter activities. Myself, I like them. I normally use them as an RPL session, just to check the knowledge of understanding of my students, so that I'll know exactly the type of a group that I'm dealing with in a classroom. The examples are detailedly placed, like I said. Examples and activities and summative assessments are all extracted from exam papers. What we did is would look at the most appearing question in question papers down from 2020 to 2024. Now, the most appearing question for that module, for that learning outcome, would use that, and would also look at the next most appearing question. And listen, would also use the same language of the examiner, just to prepare the students on what is it exactly that they should understand. Because what I've realized is that our students do not fail because they don't understand the question or what is expected of them, but it's because they don't understand the language. They are not exposed to exam languages, which makes it difficult for them to interpret them. One lecturer once said to me, you know, it's sometimes difficult to read a term when you get to the exam that is entirely new, and you need to first interpret the term in your own mother language, and then answer the term in your own mother language, and then reinterpret it in English, and then write it down. So what we're doing here is that we're exposing the learner early for those terms, so that they get a chance to interpret them in their own languages while they are still in class. But by the time they get to the exam center, they understand what is it that the question actually requires of them. The books comes with QR codes, just like N4, N5, and N6. We ensure that we create videos for critical parts of the module. Each video speaks of a certain concept in the book, where a student, more particularly, it comes in handy for distant learning students. So they can be able to scan the QR codes, and then they have the ability to also watch the video and learn. But the videos, let me put it to you, the videos are not only those that you see on YouTube. I remember there's one colleague of mine from another college who called me and said, my students and I, we're facing a very difficult challenge when we need to answer example so and so. and I still can't find ways on how to explain this. Can you make a video for me so that I can use it in class and also use it for myself to prepare for the future? We do that. We create a video for you, and of course would upload it on YouTube, and so that even anyone else who might face a challenge that we may overlook could access the video and watch. So the platform is made for us lecturers to not only watch those videos that are there, but to also request for more videos, right? We could always create those videos. We could always, develop those contents according to your requirements, to your requests. Sometimes what I did is I tried away from creating videos answering activity questions, because then I felt if you were to give a student a homework to go and write a certain activity, they'll just get access to the video and then just copy as is. But in the event where you've given the student the activity, you've also checked the lecture guide, and you could not understand what exactly is happening, the students are also finding it difficult to understand what the question needs, that is a special request. We definitely do that video for you. There's no harm there, so that in the future you can be able to watch and also assist you in preparing for your classes. So that is amazing. The diagrams are detailed, properly labeled, and they are meant for you to understand. We also bring in some reference of this diagram to real world application diagrams. So we use photographs to complement circuit diagrams so a student could understand, more particularly when we talk about ultrasonic cleaner, for an example. Some students have never seen it, or some may have seen that device, but they don't know what it's called. So if we put in the image in the book of an ultrasonic cleaner, that could jaunt their memory. It's easier to just get a name of a device that you already know. It may come in very, very handy. Vocab, in terms of the terminologies that may come in difficult for students to understand, like I said, reading something, interpreting it in your own language, getting the answer in your own language, interpreting it again to English, and then writing it in the exam may be difficult. So we expose our students long in advance before they get into the exam. And those vocabularies and new words have also been included in a glossary, where a student can just read these terms. What does this mean? Because an exam may come in and starts writing a question, blah, 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 and then speaks of an abnormal combination or other condition, and the student could not understand what abnormal condition means. So we use that at the back of the book. There's a glossary there that allows for students to check the meaning of these terms. We have, for each module, a summary where we summarize everything that we've covered in that module. So this also assists you as a lecturer. If you remember, on a lesson plan, there's this part called a review of the lesson. So perhaps you might have set a lesson plan that covers the whole module. It's up to you how you want to work that out. But then the summary should assist you to review if you have covered what's needed in the module. So that if there are some aspects that you did not cover, you could just go back and cover those aspects. There is a summative assessment that personally I use as tests for ICAS assessment, because like I said, these are exam standard assessments. So I normally just take a question from there and put it there, right? The main aim is not to trick the student, my good people. When you set assessments, that's not the main aim. The main aim is to expose our students to exam-based questions. Do not trick them, but expose them. So do not fear taking a question as is from a textbook and use it in a test. You are not giving them an advantage, but you are exposing them to understand the question. There's no harm by doing that. It is actually what's needed to be done. When a student sees this question from a textbook and they see the same question in the test, they can never forget this question. And that way they are exposed. Lucky enough, they might find it in the exam, and then you've done well. In the promo copies that you'd have, you might not see the practice exam and memo in the marking guideline. That was under construction, but now it's completed. I think in the final copy, you'd definitely have that for you to use in a classroom setting. Good people, this basically covers everything that I needed to share with you with regards to our curriculum and what the TVET first textbook would have for you. And we've also looked at all the changes that are there alongside with what now we've given you to use in a classroom setting. And this obviously takes us to the end of our presentation today. So we could use this time for discussions and ask questions. Remember, at the beginning I said you are welcome to ask a question based on the 3 levels of industrial electronics. I have time, would definitely assist you on those so that you know exactly what is it to expect in this new curriculums. Thank you, good people.
Thank you, Clifford. Whilst we wait for the questions to come through, that was a very thorough presentation, and I'm sure lecturers are now fully prepared to teach the N6 syllabus with all its changes, thanks to your excellent work this afternoon. Can we just check if anyone hasn't received a copy of the N6 textbook, a promo copy? If you haven't, what we will do is share the PDFs of this. I've got all your email addresses, and I'll attach it to emails, and we'll include the workbook as well as the lecture guide. So you'll have, if you haven't received a hard copy, you'll have at least a soft copy to go through and order this book. And also note the workbooks are available for N4, N5, and N6, and these are the TVET first books. And those of you that have used these books, I think you've gained tremendous success with your students using these books. So you'll make no mistake in ordering this book. All right, so over to the questions, feedback, what you thought of today's session. Was it helpful? Are you now prepared to tackle the changes? Anything you'd like to discuss? You now have the opportunity to speak directly to Clifford. You just need to unmute yourself and you can go ahead. Renaud? Please go ahead.
Yeah, it's a really nice book for that N6. I really like the last part for like where they talk about robotics, quite really nice also. The last time I asked you guys a question, I need this, the ebook for N4, N5, and N6, like you said now. Can you send it to me, please, man? I will really much appreciate it also.
You need copies of the N4 and N5?
Yeah, I need the ebook, electronic books for N4, 5, and N6, if you can.
Okay, we don't have, because the book has just been submitted and approved, so that will take a bit of time to get an e-copy. But we will have e-copies of the N4 and N5.
Okay, so can you email it to me? You got my email address, Mos?
I'll have it. Yeah, I will have it. I'm just going to make a note of your request. Yeah.
Yeah. Thank you so much for that. It's very nice book. So,
no problem.
Yeah, very nice.
Great. Are you using N4 and N5 currently?
Yes, I'm using N4 and we're using N4 and N5.
Okay, great. And have you received a copy of N6?
Not yet.
You haven't? Okay, so what I'll do is when I respond to your email, I will attach the PDFs for the N6.
Okay, that would be very nice. It's very nice. And N4 and N5 also is very nice. I think that also is a very nice book. I can see it. It's very
Thank you.
Good. So good.
There's a question here from Matthew Spalembe. Clifford, I want to know if there will be changes in industrial electronics N5 formula sheet as there are new calculations included.
Yeah, thanks for that question. Yeah, I think so. But what happens is that, remember, even for the old curriculum, not all of these formulas from the content book are included in the formula sheet. However, there would only be an inclusion of the critical formulas that one may need. And some of these formulas would also be easily manipulated from the old formulas. But with the content, because of the nature of the formulas, I want to believe that there won't be much, inclusion in the formula sheet, because even the curriculum is not yet or did not prescribe an inclusion of certain type of formulas. So it might be dependent on what the examiner would want to do, but there won't be, too much changes, except for those contents that have been omitted. They would also be omitted with their formulas. Thank you.
Disebo, please go ahead.
I understand that the book it's clear and it's understandable, but I do have only one concern regarding the robotics. Can't you maybe provide maybe a workshop nyana so that at least we can familiarize ourselves with the topic of robotic? Because really PLC it's also practical way, but it's explainable. But this new robotic, I don't know what is inside there and how I am gonna tackle that topic.
Clifford, did you hear that question?
Yes, I did. Perhaps what will happen is that there is some discussions around curriculum, rather content training that needs to take place in around January when we reopen the first week, where we still await for results and the likes. Perhaps what we could do is, as we are in preparation of that and seeing if that is possible, it would have been very nice if we had a WhatsApp group for all industrial electronics lecturers across the country, where we could just bring in what is it exactly that we require, so that during the training we don't waste time touching on the stuff that you may not need, but touching on specifically what each lecturer may need. I'm not sure if we can facilitate getting a WhatsApp group maybe across all lectures for all these 3 levels, and then get this feed.
What we've got are email addresses from those that have registered. We don't have cell numbers to create a WhatsApp. So I think we can look at content training early in January, as you mentioned, when you are still awaiting results. That would possibly be the perfect time to do so. So the thing is, how do we get everyone's contact numbers?
Yeah, perhaps maybe what can happen is that we could maybe share an email address or maybe I could share my WhatsApp number so that everyone could perhaps add me on their WhatsApp, and then we create a group thereof. I'm not sure what you think.
Okay, I think yeah. Why don't you post your number on the chat, and everybody can just note it and add your number to, yeah, and then you can create a group and engage with lecturers. The only thing is, people that are not attending today and maybe you could join. If you could just pass the message on to them to join the group, I think the bigger the group, the more effective and the better interaction you'll be able to have.
Yeah.
So what I can do as well, Clifford, is to send you the email addresses, and you could just maybe send out a group email, and they can just add their cell numbers to that list, so we keep growing that list.
Yeah, I think that also could definitely work. That would also work. Yeah.
Do that list to you. I just want to check if anyone else has anything to raise. Otherwise, we can. Stanley, we've addressed yours. Yeah, I don't see any further questions. So once again, a huge thank you, Clifford, for presenting all the changes to the N6 curriculum. You start with N4, took the lectures through N5, and now we conclude with N6. So yeah, you've got Clifford's contact details, and he's happy to engage with you on a one-to-one basis. So please take advantage of the opportunity. And then we will look at content training in the new year, but information will be cascaded to you. Thank you, everyone. Thank you for your time, and I hope you've enjoyed this afternoon session.
Bye.
Goodbye.